Welcome to this mini lesson on solving trigonometric equations. It should be acknowledged before we get started that here we will be covering the solution of basic trig equations. Hopefully in your pre-calculus classes prior to this point you treated more in depth the more complicated trigonometric functions and equations that would utilize factoring, for instance, or substituting in with a Pythagorean identity or a double angle identity to assist in the solution of it. We are talking about the much more simpler ones here. It's hopefully you know how to solve the more complicated ones. These are the ones typically though you're going to run into the most in AP Calculus, and that's why I chose to really just concentrate on these basic kinds. So to get started, remember that a trig equation is an equation that involves at least one trig function. As you've seen with algebraic equations, of course you're trying to solve for the variable. In a trig equation though, that variable for which you're solving represents an angle measurement. So the solutions that you get from solving trig equations are always going to be angles. So let's start with a basic example of what one looks like. Suppose we wanted to solve the trig equation cosine of x equals negative root 3 over 2. And we're asked to obviously solve for x. What that means in real English is that we're trying to find those angle values x that have a cosine of negative square root of 3 over 2. This is where your unit circle information kicks in. Another thing we know from previous trig lessons is that given the fact that we want our cosine value here to be negative, we know cosine is negative in two quadrants, in quadrant 2 and in quadrant 3. So we're going to have an answer out of each of those two quadrants. So this equation actually has two answers to it. I say that it has two answers to it, and that's assuming we are finding the principal solutions in the interval from 0 to 2 pi, essentially one full circle. That's typically what we're doing in AP Calculus. So as I mentioned earlier, your unit circle information has to kick in because looking at that problem, the fact that we want to know where cosine is a negative square root of 3 over 2, you need to think, okay, where on my unit circle is cosine square root of 3 over 2? That happens at a reference angle of pi over 6. If you think of what the ordered pair is associated with pi over 6, it's square root of 3 over 2 comma a half. Remember, it's the x value that gives us the cosine. So that's one of the first things that you would need to know. And this is why we tell you that you really need to know your unit circle. We know though that because we're solving for where cosine is a negative square root of 3 over 2, remember we're supposed to have two answers, one out of the second quadrant and one out of the third quadrant. Well, second quadrant, remember that we're working backwards with our reference angle. So we're starting at pi over on the left side of the circle, and we're going into the second quadrant pi over 6. That's where we get 5 pi over 6 as our answer. The other answer we know is going to lie in the third quadrant. Well, in the third quadrant, our angles are bigger than pi. So we're starting at pi, and we're going into the third quadrant, pi over 6. That's where 7 pi over 6 comes from. And we really are using that idea that a reference angle can be thought of as the distance between where an angle ends and the closest side of the x-axis. Another type of solutions that you will see, but not too often, hopefully again you talked of these in pre-calculus, are what we refer to as general solutions. The general solutions account for the fact that really there's infinitely many angles who will have a cosine of negative root 3 over 2. And that's coming from, if you think of the cosine curve, it goes on into negative infinity and positive infinity. So there's going to be infinitely many places on that curve where the x value is, the angle value, has a cosine of root 3 over 2. That's what we refer to as a general solution, is some way to account for that. So you pretty much would still have to figure out your 5 pi over 6 and 7 pi over 6, but to each of those you need to affix the fact that you could keep looping around the circle. Imagine starting at 5 pi over 6 on the circle in the second quadrant, and you just keep generating coterminal angles by, flipping around the circle over and over and over. So that's why we add to 5 pi over 6, 2 pi, one full circle, times n, where n is an integer. That's really just a counter as to how many times are you flipping around the circle from 5 pi over 6. You would have the same thing over in the third quadrant. Starting at 7 pi over 6, imagine just going around the circle infinitely many times using 7 pi over 6 as your starting point. Now another way you could sort of condense these, actually that's probably the easiest way. I'd probably just leave it at that. Depending upon the equation that's asked for, you might be able to condense it a little bit more. This is probably the easiest way just to do this one. But as I mentioned earlier, typically what you're going to see is that you're asked to find solutions just in the interval from 0 to 2 pi. So that's what we'll be concentrating on here. But before we dive into doing them in our heads by hand, let's talk a little bit about how to use our calculator. Once in a while you'll come across these, so I definitely want you to know how to solve them. Most of the time it's the unit circle related ones, but you will occasionally find ones that you'll need to really use your calculator to help you solve. So here's an example of one. Suppose we want to solve tangent of x equal to negative 0.45, where x is an element of 0 to 2 pi. So that's just telling us that we're trying to find an answer in between 0 and 2 pi. We do need to be in radian mode on your calculator. Right? Typically in calculus, we are always in radian mode. So to get to radian mode, just hit the mode button on your calculator. You'll notice the third line down is radian. You'll want to have that one marked. That one right there. Pretty much for calculus, put your calculator in radian mode and leave it there. So going back to the instructions then, right, we do want to be in radian mode. We are going to use the inverse functions on our calculator to solve these. So we would do inverse function of 0.45. Now notice I'm saying to leave out the negative. The negative, I recommend you don't even put it in your calculator. The negative is really just helping you know where your answers are going to lie in which quadrants. All right, so for instance, in this one, tangent's negative. So you have to think about between all 4 quadrants, where is tangent negative? All right, that's going to tell you in what quadrants your answers lie. All right, so let's actually go ahead and solve this one. So going back to the calculator, all right, we're going to do inverse tangent, second tangent of 0.45. This answer you get represents your reference angle. You're better off typically storing that. Remember to store something on your calculator. You do stow in the far left column down towards the bottom. And just pick a variable. I'll pick A because angle. But you really can pick any letter you want. And then just hit enter. In AP Calculus, we typically round to thousands. But the expectation is as you're using decimals, you're going to work entirely in your calculator. So storing values such as this is something you'll be doing a lot of. All right, this represents our reference angle. Now this is in radians. All right, so we're talking our reference angle for this problem is 0.423, if we round to thousands, radians. All right, so let me switch back to the lesson for a moment. All right, so that becomes our reference angle then. Sometimes you'll see, you know how you have the little degree bubble for angles and degrees? Sometimes you'll see people put like a little r kind of as an exponent to indicate, kind of a reminder that it's radians. Otherwise, if you see nothing there, we assume that they're radians. All right, if it's a degree measurement, you're going to put the little degree bubble. All right, but this is one thing I know I got into the habit on. I think it was drilled into my head at an early age. So that's the first thing you'll want to do, is figure out your reference angle. Now we're going to figure out where our answers are going to lie in. Well, remember, tangent is negative. So you need to think, in what quadrants are tangent negative? So that's going to be in the second quadrant that tangent's negative, and also in the fourth quadrant. We're going to have an answer out of each one. All right, well, remember that if we're talking an answer in the second quadrant, draw a picture. All right, here's where your angle starts, right here. We're trying to figure out where this angle ends. So this part in here, that's your point 423 for your reference angle. All right, so in order to determine our answer in the second quadrant, our angle, theta, that we're trying to find, I guess it's x, actually. Let me correct that. You're going to start at pi. You're going to go into the second quadrant, 0.423 radians. So let's go back to the calculator real quick. So we're going to do pi minus what we have stored as our angle. So our first answer is approximately 2.719 if we round to thousands. Approximately 2.719. Again, if you find it helpful to put the little r to remind you it's radians, feel free. All right, we'll color code. All right, our other answer is going to be in the fourth quadrant. So here's where our angle would start. And now we're trying to figure out the fourth quadrant answer. All right, so pretty much finding this big angle there. All right, this little part in here, this is the 0.423. All right, remember, by definition of reference angle is that distance in between where the angle ends and the closest side of the x-axis. So in order to get our angle for this one, we're starting at 2 pi, and we're going into the fourth quadrant, 0.423 radians. Go back to the calculator real quick. So we have 2 pi minus what we stored as the reference angle. And our other answer is approximately 5.86. Right, so they would be the two angles in terms of radians whose tangent values are a negative 0.45. And these are really easy to check. You could easily just do the tangent of 2.719 and do the tangent of 5.86 on your calculator, and you should get pretty close to a negative 0.45 for each. All right, let's try another one with our calculator. Let's do a sine problem. All right, so now we're trying to find the angles where sine is a negative 0.7. So let's start by just figuring out what quadrants we have to be in. Well, sine is going to be negative down underneath the x-axis. So we're going to have one answer in the third quadrant. We're going to have one answer in the fourth quadrant. All right, so let's go back to the calculator. Clear all this stuff. All right, so we want to do inverse sine in order to find what our reference angle should be. And remember, we're just going to do a positive 0.7. Right, and hopefully everybody gets this 0.775 approximately as your reference angle. So I'm going to go ahead and store that. There we go. All right, so our reference angle then is 0.775 radians. All right, so let's do our third quadrant answer first. All right, so if you envision, here's where your angle starts. In your third quadrant, so we're trying to find how big this angle is here. All right, our reference angle, that's the 0.775. That's this little distance in here. All right, so we want, in order to get x, we're going to take pi and we're going to go into the third quadrant, 0.775. Go back to our calculator. All right, so we're going to do pi plus what we stored as our reference angle. And hopefully everyone gets approximately 3.917, rounding it off. All right, so we got one answer. Our second answer is going to lie in the fourth quadrant. So you're starting here, and you're going all the way around. So this big angle here, this angle squeezed in the middle there, that's your 0.775. So to get our answer, we're starting at 2 pi, and we're backing into the fourth quadrant, 0.775 radians. So we have 2 pi minus so we get approximately 5.508. So that's how you would use your calculator to do problems such as these that are not unit circle based. But let's turn next to the ones that are unit circle based, so no more calculator. All right, here's another type of equation that you'll actually have to rearrange first. So if we go ahead and this time we want to get cosine of x by itself, so we have cosine of x equals a negative a half. So notice how now it looks similar to what we had before. It's really up to you to know your unit circle well enough to recognize when you have a unit circle problem on your hands that you should be able to do in your head. Anytime you're coming up with values like 0 or 1 or a half, 1 over root 2, square root of 3 over 2, all those different coordinate values associated with the unit circle, that's how you know it's a problem that you're really expected to do in your head. But we're going to go about it the same way. All right, cosine is negative, so the first thing you want to think of is where is cosine negative between all four quadrants. So cosine is going to be negative over in the second quadrant and in the third quadrant. So we're going to have an answer out of each. All right, next thing you want to think of is what the reference angle is going to be that you need. So you have to think of your ordered pairs from the unit circle. Cosine, remember, always relates to the x coordinate. So you need to think, all right, where on my unit circle is the cosine value, the x coordinate, a half? So hopefully you're coming up with the fact that your reference angle is pi over 3. Because the ordered pair for pi over 3 is a half, comma, square root of 3 over 2. So the half, that is your x coordinate, that is your cosine. So now you know what angle to be using to generate your final answers. So in the second quadrant, all right, you just need to think of using pi over 3 and get an angle with that reference angle in your second quadrant. So technically you're doing pi minus pi over 3. So your answer is 2 pi over 3. So that's one of your answers. The one in the third quadrant, you're starting at pi. You're going into the third quadrant, pi over 3 units. That gives you 4 pi over 3. I'm sure you'll eventually get to the point that you can do most of this in your head and just come up with the final answers. I'm showing you all the steps that would lead you there just to make sure everybody understands where we're getting these final answers from. All right, let's try another one. So this one relates to cosecant. So we're going to go ahead and do our rearranging to get cosecant by itself. So we have 2 over square root of 3 when we do that. Well, typically it's going to be easier to think in terms of the main trig functions, sine, cosine, and tangent. So we might want to go ahead and turn this into a problem relating to one of those main functions. All right, so remember cosecant is the reciprocal of sine. Well, if cosecant is 2 over root 3, do the reciprocal of that, that must give you the sine value. So what we're really trying to solve is the problem sine of x equals root 3 over 2. Anytime you have a trig equation involving the reciprocal functions, it's probably easier to turn it into an equation involving one of the main 3 functions. So now we're just going to go for them from this point. So we're trying to think of where is sine value positive, because that's a positive square root of 3 over 2. So sine's going to be positive in quadrant 1. So once we have our reference angle, well, that's your quadrant 1 answer. Our other answer is going to be in quadrant 2. So now this is where you want to think of your unit circle values again. You want to think what angle on the unit circle has a sine value, meaning a y coordinate, of square root of 3 over 2. So hopefully you're coming up with your reference angle is pi over 3. So that's your first quadrant answer right there. To get the second quadrant answer, remember you're starting at pi, you're backing into the second quadrant, pi over 3. You get 2 pi over 3 as your answer. All right, so let's do one that's a little bit trickier. Secant squared of x minus 1 has to equal 0. So if we go ahead and rearrange, we have secant squared of x equals 1. So if we take the square root of both sides, we get that, we do have to keep in mind the square root of 1 is both positive and negative 1. But just as we saw before, we are going to turn this into one of the main 3 trig functions. So we have here secant. Reciprocal of secant is cosine. So if we just do the reciprocal of either a positive or negative 1, well, we pretty much still have the same thing. So what you're trying to think of now is you're trying to find the angles in between 0 and 2 pi, where cosine is going to be positive 1, but it's also going to be negative 1. So you pretty much have 2 problems to solve, because you have cosine of x equaling 1 to solve, and you also have cosine of x equaling negative 1 to solve. All right, so think about your unit circle. If cosine is either 1 or negative 1, that means on the unit circle, what angle has an x coordinate of either 1 or negative 1? Well, in these cases, your angles that you're trying to find are actually quadrantal angles. All right, so this first one, where cosine of x equals 1, that's 0. Notice how we do not include 2 pi. That's going back up to this. Notice how your interval is open on 2 pi, so we are not including it. All right, so it would be wrong to say in this case your answer is 2 pi. We defer to using 0 instead. For the second problem you had to solve, where cosine's a negative 1, that's over here on the left side of the circle over at pi. So they become your 2 angle answers for this one. And we have one more. This is probably the one that students perhaps saw the least of in pre-calculus, but it is definitely something you need to know how to solve. So we're going to do some rearranging first. So we'd have sine squared of 2x. We're just going to start by dividing both sides by the 2. That was in the very, very front. So that puts us there. Next, we're going to take the square root of both sides. When we take the square root of 1/2, all right, again, we do have to consider both the positive and negative root. All right, and once again, we sort of had two problems to solve. All right, you have where sine of 2x equals a positive 1 over square root of 2, and you have sine of 2x equaling a negative 1 over square root of 2. So hopefully you're already starting to think about what your reference angle is going to be. The catch on this one is you don't have just plain x, you have 2x. So it's not as simple as just saying x equals whatever you have. It's really 2x equals whatever you have from the unit circle. All right, so let's break it down bit by bit. We're going to do sine of 2x equaling a positive 1 over root 2 first. All right, well, you'd have to think about what quadrants you're going to be in. All right, if sine is a positive 1 over root 2, sine is positive in first and third quadrants. Or first and second quadrant, rather, sorry. All right, well, you'd have to figure out somewhere along the line that the reference angle you want to be using is pi over 4. All right, so that becomes our first quadrant answer. So we have 2x equals pi over 4. So dividing both sides by 2, we have pi over 8. All right, but this is the catch, because you're supposed to find all angles in between 0 and 2 pi that would work. So when you think of pi over 4, well, what if you went all the way around the circle again from pi over 4? Pretty much did another coterminal angle. If you start at pi over 4 and go around a complete circle from there, you land at 9 pi over 4. I mean, that's still in this first quadrant. That's 2 and 1/4 pi. When you divide by 2 then, you get 9 pi over 8, which is still another possible answer. So in the end, this one's actually going to have 4 answers. Actually 8, because that's just the first quadrant. All right, all this stuff right here, that's your first quadrant. All right, now we have to consider second quadrant, because remember we were trying to figure out where sine was a positive 1 over root 2. Well, over in the second quadrant, well, that could be 3 pi over 4. Divide that by 2, you get 3 pi over 8. All right, but again, you're trying to find all angles in between 0 and 2 pi that could work. So if you start at 3 pi over 4, go around a whole circle again, so essentially do 3 pi over 4 plus 2 pi, you get 11 pi over 4. Divide that by 2, you get 11 pi over 8. So now you got 2 more. This is from when your answers were in the second quadrant. So far you have 4 answers: pi over 8, 9 pi over 8, 3 pi over 8, and 11 pi over 8. Now we have to go through the whole same thing again, but now sine being negative. So we know sine is going to be negative down in quadrant 3 and quadrant 4. All right, so think of the third quadrant using pi over 4 as your reference angle. So if you do pi plus pi over 4, that gives you 5 pi over 4. All right, divide that by 2, you get 5 pi over 8. So there's another answer. All right, But imagine starting in the third quadrant at 5 pi over 4 and going around a complete circle back to that same place. So if you do 5 pi over 4 plus 2 pi, you get 13 pi over 4. Divide that by 2, you get 13 pi over 8. And the reason you're having to do this is because, again, remember what you're trying to find. You're trying to find all values of x in between 0 and 2 pi where this relationship will work out. So these are the answers from being in the third quadrant with your angle. All right, so now we got fourth quadrant. So using that pi over 4 as your reference angle, going into the fourth quadrant, that's 7 pi over 4. Divide that by 2, you get 7 pi over 8. Now imagine starting at 7 pi over 4 in the fourth quadrant, going around a complete circle from that point. So do 7 pi over 4 plus 2 pi. That gives you 15 pi over 4. Divide that by 2, and you get 15 pi over 8. So all this stuff is from the fourth quadrant. All right, so the answers that you have in the end, you got these two, these, and these. Now you don't see these often, but you will see them. So when you do come across these in AP Calculus, you need to know how to handle them. All right, but this is how they typically will work out. As you do increasing powers of the trig function, like in this case it was squared, that's going to increase how many answers you have. You typically won't see anything above squared though, so this is really the most you would ever have. So as I said at the beginning, remember these really cover just the basic trig equations. They do leave out all those trig equations that would require factoring or substitution with a Pythagorean identity or double angle identity. These are really just the basic mechanics of how to go about solving. So hopefully this helped you out a little bit.